How does Python pass data to a function? And how is this data then affected by this function? In this video, we are going to talk about Python copies, references, pass by assignment, and none. Welcome, I'm Cons. I got a master's degree in computer science and currently work as a graduate research assistant, and I'm here to help you to learn computer science with Python. In the videos about Python lists, tuples, sets, and dictionaries, you've learned the difference between mutable and immutable data types. And if you want to check back on those, check out those links up here. In those videos, we've used a lot of Python built-in functions to either change our data or to find out certain properties of the data. And now let's take a closer look behind the scenes how this data is passed to a function and how that might affect your program. First up, there are two ways we can pass data to a function. The first one is we pass the data directly. So here we use an arbitrary function print, and then we enter the values we would like to pass to our data. First we have a 1, and then we have a list containing two values a and b, and when we enter print we can see it prints out 1 and the list ab. The second way we can pass data to a function is via a variable. So first we store our 1 in the variable I, and then we assign L to a list containing a and b. And then we can call print once again, and this time we are not going to pass 1 and ab, but we're going to pass I and L, which are referencing the data we have just created. And we get the exact same result. The difference between those two methods of passing data to a function is that the second one allows you to access the data even after you have passed it to a function. So we can still access L, and we can even change L here, so we can pop a value from L and so on. When primitive data such as bool, int, float or string, or immutable data such as tuple is passed to a function in Python, all the values contained in that data are copied over into that function. That means if the data is changed inside the function, the data won't change outside of the function. This is called pass by value. When immutable data types such as lists, sets or dictionaries are passed to a function in Python, the data isn't copied over. Only a reference to that data is passed to that function. And this is called pass by reference. And when the data is then changed in the function, it also changes outside of that function. The difference between pass by value and pass by reference might sound very theoretical at the moment. So therefore I prepared a little example to make it clearer. So over here I created a program where we first assign the value 1 to the variable I, which is an integer and therefore it's a primitive data type. And then we assign the list AB to the variable L, and the list is a mutable data type. Then I defined a function myself, and that function takes the values x and y, and we pass I as x and L as y. And inside that function, we're changing the data. So from our integer, we're going to subtract 1. And from our list, we're going to pop one element. And after we have run the function, we're going to have a look at the data with this print statement. So let's run that. And we can see that I is still 1, even though we subtracted 1 and assigned it again to x in our function. However, if we have a look at L, L is only a because we popped one element from it. And this is the difference between pass by value and pass by reference. While I is a primitive data type, it was passed by value. That means the 1 was copied over into the function and then stored in x. So every change we do to x in that function won't be present outside of the function. While L is a mutable data type, it was passed as reference. So every change we make inside that function is also reflected outside of that function because we only work on a reference to our list inside the function and not with a copy. If you want to avoid that the changes that are made to a mutable data type inside a function are also present outside of the function, you have to pass a copy of your mutable data type to that function. And to do so, we are going to add a dot copy after our list, and that will create a copy and then pass the reference of that copy to the function we are calling here. So if we run that again, we can see this time A and B are still in that list, even though one element is popped from the list inside that function. And this is because we are only passing a copy of that function as a reference to that function and not the reference of the list itself. It doesn't matter if you're new to Python or if you're a seasoned programmer. Everyone likes cheat sheets. And I actually prepared several cheat sheets you can get for free as a high-resolution PNG in my Gumroad shop. And you can even get a printable PDF version of those cheat sheets for a small amount of money in my Gumroad shop or for every tier 1 or higher Patreon subscribers. So make sure to pick up your free Python cheat sheets by clicking on the links down below in the description. To check if two variables in Python reference the same data, you can use the is operator. So first I prepared a list A, B, C, and then I'm going to assign M to L and then N to a copy of L. If we now check if M is equal L, that will result in true. And if we check N is equal to L, that also results in true, because all those lists have the same values, as we can see when we enter them here in our interactive mode. But we can also check if they reference the same data or not. And for that we're going to use the is operator. So if we check L is M, we get true, because M references L, and that is just a reference to this list. So L and M are referencing the same data. If we use the is operator reverse, we can also see that is true, because M and L still reference to the same list. If we use N is L, this will result in false. Even though they contain the same values, those lists are not the same and they reference different types of data. So if we use L pop, we can see C is removed from our list, and when we print out L, we can see AB is only still present in the list, and we can have a look at M, and M also lost the C because they referenced the same data and the pop was called on that data. And if we have a look at N, and we can see N still has the C because N is just a copy of that list and references to a different type of data. Each piece of data in Python has a unique ID. And those IDs are used to compare the references to each other. So if we have a look back at our examples of the list L, M and N and use the ID function on L, we can see that it prints out a long number which is different every time you run Python. So if we check the ID of M, we can see M and L have the same ID. So the is operator, L is M, is actually implemented as a comparison operator between the IDs. So if we enter ID equals ID M, we can see that also results in true. If we have a look at the ID of N, we can see that N has a different ID than L and M. And we can also compare that. L equals ID N, we can see it is false. This unique distinction between pass by value for primitive and immutable data in Python and pass by reference for mutable data types is called pass by assignment. And if you start working with Python more often, you will come across the pass by assignment a lot more often. If you enjoyed this video so far, make sure to give it a like so it can spread to more people and more people can start to learn about Python copies, references and pass by assignment. Now that you know the difference between copy and reference in Python, there's one last thing we need to talk about, and that is none. None is used to represent the absence of every value in Python. And if we would like to use none, we can just assign a variable to none. So here we have the variable a and enter none. And we can also assign another variable to none, which is b. And now we can check if a equals b, that is true. And we can also check if a is b, which is also true, because there's only one none, which we can show by using id on none, and then id on a, and id on b, and all of those have the same id. None actually has its own data type in Python, so when we enter type none, we can see we get the none type, which is the type that represents none. You might ask yourself now, What is none good for? None can be used to indicate that a variable exists but doesn't have a value assigned to it yet. So if we have a look at this little example program, the variable x will only be assigned the value 13 if b is greater than 23. If b is not greater than 23 and we use this without the none up here, so let's check that out. We turn b to 13 and run that program, we're going to get a name error that x is not defined. However, if we assign x to none first and run that program, we can see we don't get an error and we just print out none. And if we change b to a larger value than 23 to 42 and run that program again, we can see that x is now assigned 13. So none can be used to set a default value that doesn't represent any value in Python. I hope this video was helpful for you. And if you got any questions regarding copies, references, pass by assignment, or none, leave them down below in the comments. Make sure to pick up your free Python cheat sheets from my Gumroad shop or my Patreon, with a big shout out to my Patreon subscribers. Don't forget to subscribe and hit the bell icon so you get notified when I release a new video on computer science, programming and Python. And if you want to learn about Python loops, check out this video up here. I wish you a fantastic day and hope to see you soon. Bye bye!